Before we begin with our session, I would first like to introduce our chair for the session, Mr. Tahir Maqsood. Mr. Tahir Maqsood is a geophysicist by profession with 38 years of experience in national and international oil and gas companies. After completing his master's in geology from University of Balochistan, he joined GSP. Later, he resumed his career in OGDC for 16 years and 18 years in Talo. He was also the Director Technical in IPR up to 2022. He has contributed in oil and gas for prospect generation, regional studies, basin evaluation, and oil and gas asset evaluation. He remains a very prominent member of PAPG Forum as a reviewer, as technical chair, leading field exertions, student workshops, and author of multiple papers. Everyone, please welcome him with a round of applause. Our co-chair for the session, Mr. Maas Siddiqui. Mr. Mohammad Maas Siddiqui is a senior manager exploration at PEL. He got his MSc Geophysics degree in 1980 from Quaid-e-Azam University. He joined OGDCL and has an experience of more than 40 years in the E&P sector. Everyone, please welcome him. I would like to tell all the students the rules before we start with our paper today. You will all have 15 minutes for the paper presentation. The first 10 minutes, after the first 10 minutes, you will hear a buzzer, which means you have 5 minutes remaining and you should start to wrap up with your presentation. Once the 15 minutes are over, then we will have the question answer session, which will be of 5 minutes. Let's begin with our first paper for the session, which is Sedimentology and Geochemistry of Jhil Member Gaj Formation Miocene Age southwest of Karachi, Pakistan by Huzaifa Ahmed.
Assalamu alaikum everyone. Good morning. Today I am here to present my research work entitled Sedimentology and Geochemistry of Jhil limestone occurring in this Miocene age occurring in the southwestern part of Karachi, Pakistan. I am Huzaifa Ahmed and my co-authors are Muhammad Shumail and Sumer Asif Khan. Let's move to the introduction. Limestone basically is the sedimentary calcareous rock composed of calcite with other gangue minerals. It comprises approximately 10% of the sedimentary rock exposed on the Earth's surface. Jhil limestone is a thick predominant unit of creamy white color to creamy white to light brown color calcareous, thick, hard, resistant, and coralline and foraminiferal in composition. It was deposited in a regressive phase of sea when the western axial belt was uplifted. It is also to be considered as a refill in origin. The study area is located in the western coast of in the western part of Karachi near the Arabian Sea. It marks the southernmost extension of the Pub range. Here we can see in the geological map of the area these formations are continuously exposed from the western coast of Karachi to the northern Sindh, forming a series of asymmetrical fault plunging southeast. In the next slide, we have the elevation map of the area. The area is characterized by small hill topography less than 250 meters above the mean sea level, where the hogback and cuesta type of ridges are found, and the drainage pattern of the area is dendritic, where the different order of streams meet the main ephemeral hub river. In the material methods, total 15 samples were collected with a difference of 10 feet, which marks the 150 feet thickness of the unit. The weathered surface of the rock was removed, and then a fresh piece of rock was collected in a sample bag. Then the sample preparation, the sample were pulverized to very fine size powder, passing through 200 mesh for XRF studies, and thin section slides were made for the petrographic studies. For geochemical analysis, the prepared sample were carried out for XRF, which determine the elemental composition of the rock, while the petrographic study were done to determine the carbonate rock as per Venom and Fogg classification. In the results and discussion, total 5 number of samples were selected for geochemical studies. The analysis were obtained through XRF, and the measured component are here in the XRF shows that the major constitute of the rock is calcium. Then we have silica, iron, aluminum, magnesium, potassium, manganese, and sodium. And the major constitute is limestone because of the calcite present in the rock. We will further discuss it in the next slides. Here is the correlation coefficient of the elements of the gel limestone. We have considered 0.5 as a significant value, and the red square boxes show the positive and negative correlation between the elements. The silica, here we can see the silica has positive correlation with aluminum, magnesium, sodium, and potassium, and a negative correlation with calcium. Aluminum has a negative correlation with calcium and positive correlation with magnesium, sodium, and potassium. We will further discuss it in the upcoming slides. The silica content increases when we move to the upper contact of the gel. The composition of silica is ranging from 4.02 to 2.09%, with an average of 2.914, which is contributed by the clastic minerals such as quartz. Here we can see in the graphs it show the silica has a positive correlation. When the concentration of silica increases, the aluminum concentration also increases. Here we can see in the magnesium, it has also positive correlation. In sodium and potassium, it shows also positive correlation with these. And it has negative correlation with calcium, which showing decreasing trend, while when the calcium content increases, the silica concentration decreases. The aluminum content varies in the gel limestone from 1.2 to 0.58, with the average of 0.812%. When you move to the upper contact of the gel, the aluminum concentration increases because of the clay minerals, and it has positive correlation with magnesium, sodium, and potassium, and it has a negative correlation with calcium. The gel limestone is a pure limestone with very minimal concentration of clay minerals such as aluminum. In the next, we have iron with the minimum value of 1.8, with the maximum value of 1.972, with the minimum value of 0.6%, with the mean of 1.274%. The iron concentration doesn't show any increasing or decreasing trend while moving to the upper part of the gel. It has positive correlation with manganese and negative correlation with magnesium. The CO concentration ranging from 53.41% to 49.87, with the mean of 52.03 due to the calcite mineral present in the limestone as a major constituent. The CO content shows decreasing trend while moving to the upper part of the gel member towards the Thelava limestone. It has a negative correlation with all with all such as magnesium, sodium, and potassium. Next, we have magnesium. The magnesium content increases as we move to the upper contact of the gel member. The composition of magnesium varies from 3.04% to 0.35%, with the average of 0.958%. It might derive from the skeletal debris of the magnesium containing fossils. It has positive correlation with sodium, calcium, and negative correlation with manganese. In the next, we have sodium, which varies from 0.06 to 0.03, which is probably induced to the skeletal remains of the fossils, and it has positive correlation with calcium, sodium, potassium. And next, in the last, we have the potassium with the minimum value of 0.1 and the maximum value is 0.26% with the mean of 0.16, which is most likely introduced to the skeletal remains of the organism. And the composition of potassium is increasing while moving to the upper part of the gel member. Here is the petrographic results of the thin section. The major constitute of the where we classify the carbonate rock as per Dunham and Fogg classification. The majority of sample are classified as wexstone as per Dunham classification and sparse biomicrite as per Fogg classification. And the upper contact where the concentration of aluminum or other minerals were increasing classify as mudstone as of Dunham classification and fossiliferous biomicrite to micrite as per Fogg classification. And it was also be observed that the cement is micrite predominantly and the fossil content varies from 30 to 50%. And this summary of petrographic study of all sample has a wide variety of forum, coral, algae and gastropods. Here's the photo micrographs of the sample. Here we can see the Lockhart fossil, Myogypsina, and Lepidocyclina, algae, and orbitalite. And the cement content here we can see is dull cement, which is micrite. And in the sample 14, which we classify as mudstone, doesn't show any fossil content. In the conclusion, we can say that the geochemistry through XRF show the gel limestone is a high purity limestone because of the calcite as a major constituent, and it can be used in many industries such as cement industry, ceramic industry, adhesive, sealants, etc. The majority of sample appears as a low magnesium calcite. Petrography revealed the micrite to sparse biomicrite class of carbonates as of Fogg classification and mudstone to wexstone as of Dunham classification. It was also observed that the cement is micrite predominantly and its fossil content majorly varies between 30 to 50%. Paleontological, mineralogical, and geochemical evidences suggest that the gel limestone of Gulch Formation is a coralline algal reef framework. Facies indicator elements show that the majority of bed belong to the forereef flank of some with some algal banks, and the fossil found in the gel limestone are the representative of shallow water environment. In the acknowledgement, I would like to thank Mr. Muhammad Adnan, CEO, APEC Intercon, for providing analytical facilities, and I'm also thankful to my class fellows, Mr. Amjad Hussain, Mr. Abdul Hamad, Ms. Sina Shahid, and Ms. Muqaddas Nas for their support. Here are the references, and thank you so very much.
Thank you, Zafar. Well in time, good preparation. And we have now 5 minutes for the question and answer. If you have any questions, please raise your hand, identify your name, and then we will ask the question. Please. Anybody? Are you sure? No question? Please. Please identify your name.
You have mentioned that the magnesium content is increasing due to the skeletal debris. Did you find any dolomites in this area?
Yes, in the thick section slides, we find the dolomitization, which shows the yellow shade of yellow shade in the thin section, which we identify as a dolomite.
So, do you think that magnesium content is due to the dolomites also?
Maybe it can be due to the dolomitization, or maybe due to the skeletal debris of the magnesium-containing fossils.
Thank you.
Thank you, Zafar, for the wonderful presentation. Can you go to your conclusion slide, please? Yeah, you mentioned that the environment is shallow water. Shallow water is very wide term. Can you specific? Can you describe specifically which shallow water environment are you talking about?
Sir, usually the limestone precipitate in shallow marine environment, in calm and quiet environment. So, I didn't get your answer, your question.
Different types of shallow marine environment there are. So, as you mentioned, shallow water only. So, my question is, which specific shallow water environment have you find out?
No, sir, I didn't.
Okay, thank you.
Any more question? Thank you very much. So we move to the next paper.
Thank you, Josefa. Now the next paper we will have is on micro-CT X-ray computed tomography analysis of reservoir sandstone, a methodological approach by Mohammad Uwais Haider.
Assalamu alaikum everyone. My name is Mohammad Uwais Haider and today my topic of presentation is micro-CT computed tomography analysis of reservoir sandstone. Here are some key outlines regarding my work. I will proceed with the introduction, then come to the XCT framework, and then the methodology I have obtained in my research work, and then finally the results, and at the end recommendations and conclusions, and we will talk at the end what future work can be done on this. Here we can see that the digital rock modeling is an intriguing technique in the field of geosciences and petrophysical analysis. I have attached a CT render scan of 3D images, which is helping us to analyze that the blank portion in this rendered model is presenting the pore space, and the dark color is showing the mineral phases in it. We know that the digital rock modeling is help us to completely visualize and reconstruct the internal structure of reservoir characterization. Here we can see that when a pore space segmentation is applied on this model, it shows that how much area of pore space is carried out in this sample. Further, it is showing that the how pores are separated, different colors are presenting different pore sizes. I have attached a sandstone image which is showing that just a thin section view and a SEM view. In thin section view, we can see that the sandstone particles are completely packed together, and it is not possible for us to clearly view that how much pore space is present in this section. And in scan image view, we can also see that it is also difficult to determine that how much pore space is present in this formation. So we use DRM to describe that how much fluid flow is moving within the rock particles, how the velocity field is changing, and how the fluid is moving within the rock particles. So why we are using digital rock modeling? We have seen that the other conventional microscopic techniques are not able to present the 3D visualization, and these techniques are only able to provide us the 2D structure and fabric of the rock formation. Here we can see that the DRM model attached is presenting the complete 3D view of that how pore space is provided in this model and how the segment grains are inside this model. So what we are going to do, what is the objective of our work? I will be working on that how pore size distribution is carried in this model, and how the fluid flow is, and how we can how we can provide pore network modeling using DRM. So XCT framework. XCT basically itself is a very broad topic, so we are just going to a little bit about it. So X-rays help us to determine that when a sample is placed over the XCT stage, it rotates continuously, and then the image is then when the X-rays are bombarded over the X-ray sample, this sample rays pass through the pore space, and when the attenuation value of the X-rays bombarded over the sample, it provide us image. How much denser the image is, you can see that the more sharper view of XCT 2D slice we can obtain. And with the help of this model, we can process it and further provide a digital rock model. So why we are using X-ray computed tomography? Because it is a non-destructive technique. It helps us to multi-phase analysis. We can determine the 2D, 3D, and 4D image as well. And we can integrate XCT with the help of computer simulation models to further perform our machine learning techniques. And it truly represents the internal structure, which is difficult in other microscopic techniques and other procedures. So beginning with the methodology, we can see that we have selected a turbidite sandstone sample of the reservoir, which is nearly 4 mm of diameter and 2.5 mm length was selected, and XCT images were generated from this sample. After generating XCT images, we brought this sample into a resolution of few micrometer, and then the further processing were done over this model. So what is the methodology we have used? We have used different softwares for this work to be performed. Mira Aviso was a basic software which was used for the all segmentation, pore network modeling, and other processes. And we can, our methodology start with first of all, ortho slices were bring, and after generating ortho slice, phase segmentation was done. After phase segmentation, we used to provide the pore network model and generate the absolute permeability and flow relation within this model. So here is the complete workflow. First of all, we generated an ortho slice. In this ortho slice, we can see that the image is a little noisy. So for denoising this, we applied a filter on this filtered image, which is truly showing that how the pore space and segments and grains are separated and present in this section. After this, we applied the total porosity, and which is shown in red, and further the phase segmentation processes. After generating separating total porosity, we use grains. After that, we find out how much cement is present in there, and after that, the clay component in this sample. And a complete model of segmentation is presented here. After this model, its labels were interpolated, and further moving towards our next process, its labels were then helping us to provide a pore network model, that how pores are attached with each other, and which is helping us. The pore throats are connected, can be seen in this slide, that how the pores are connected with each other and how it is structured in this pore network model was further applied to a pore size distribution, that how many number of pores are of same size and how pores are vary in different sizes. After this, permeability flow was applied at this section. I think so. So it is not working. You can see that the illuminated streamlines within this model were absolute permeability flow. To count the absolutely permeability flow, we provide an flow from inlet, and it is moving out of the outlet, which is showing that how much permeability can be observed and can be find out with the help of this model. Here are some results of my total work. First of all, I obtained a result of 9.3%, 31% of total porosity was obtained, and we can see that some particles are isolated. So we know that in reservoir characterization and fluid flow, effective porosity is mostly probably required. So for interpolate, after this, I applied axis connectivity on this model, and then effective porosity were calculated, which is showing that 8.71% is effective porosity in this model. Attached is the chart of this work, where you can see that the mostly particles of a same diameter or mostly size are range from 20 to 45, and the maximum radius of the volume is 14,000 nearly. So after that, I have attached a pore network model, which is completely showing its internal structure, that how these pores are connected. You can completely see that there are total 228 pores which are connected with these throats, and number of throats were 362, which are helping the pores to connect, and the flow can be easily passed through them. And the sizes of pore and the coordination number, that how many number of pores are connected with each other and how many pores are separate. So we observed that only one pore was separated from others, and maximum pores connected found were 11, and average of pores connected with each other are 3.17. After that, we applied the absolute permeability flow with the help of Navier rock flow, which is help us to determine that how much permeability is present in this rock sample. Here we can see that when we applied the flow from inlet in z-axis, it is moving out of the z-axis outlet. And further, the pressure was for permeability flow, which is shown can be seen that the fluid flow velocity is dependent upon the tortuosity of the pore network model. Here you can see that the results we have found that the total flow we provided is 4.53 and 10 raised to power 10 rate per second micrometer. So if after that we applied the flow in y-axis and same for the z-axis. So we have obtained that in z-axis we obtained the maximum flow, and the lesser flow was in y and x-axis. So why it is lesser in y and x-axis? Because there is no outlet in y and x-axis. That is why the flow rate is lesser in permeability in y and x-axis. So we determined that the fluid flow is mostly dependent upon the